Hello and welcome to TechScope News. I'm Tiffani Neilson, and joining me as always is my incredible co-host, Johannes Beekman. How are you doing today, Johannes?
I'm doing great, Tiffany. How's your day going?
Amazing, thanks for asking. And Johannes, when I look at this month's headlines, I keep coming back to one phrase, the autonomous economy.
And I think that's exactly what's happening, Tiffany. For years, we've been talking about artificial intelligence as a tool, and this month, AI is becoming part of how economies operate.
And not just economies, factories, data centers, supply chains, hospitals, power grids, cybersecurity systems.
And even corporate organizational charts, Tiffany.
Exactly. We're seeing technology move from assisting decisions to increasingly participating in them. And that changes the conversation.
And yes, Tiffany, so because once systems begin acting, coordinating, optimizing, and operating at scale, the question isn't just whether they work, it's whether the institutions around them are ready for them to work.
Well, today we're covering Anthropic's rise toward a $1 trillion valuation, Google's latest AI agent push, the global compute arms race, AI driven manufacturing, robotics entering the workforce, Meta's AI restructuring, industrial IoT expansion, cybersecurity challenges from autonomous agents, quantum networking breakthroughs, medical advances, the Vatican entering the AI conversation, and one quantum experiment that's making physicists question where reality itself draws the line.
Always reassuring, Tiffany, when that month ends with scientists saying we're no longer entirely sure what's real.
That usually means it's time to begin. So let's begin with what may be the biggest AI business story of the month. Anthropic raised fresh capital at a valuation approaching $1 trillion and reportedly moved closer to a public offering.
Which is absolutely extraordinary, Tiffany, if you consider how young the company still is.
And what stands out to me is what investors are actually buying. They're not investing in a single chatbot, they're investing in future infrastructure.
Exactly. We're talking about models, we're talking about enterprise platforms, we're talking about developer ecosystems, agent systems, cloud services, safety frameworks. The market increasingly views these companies, and Anthropic is just an example, as foundational technology providers.
Which raises an interesting question. Are we watching AI companies turn into infrastructure platforms that economies depend on in the way that they once depended on electricity or telecom?
Well, once capital starts flowing into infrastructure at the scale that we're seeing right now, the next question becomes what those systems actually do.
Well, Google made some of the biggest AI announcements of the month, unveiling new Gemini capabilities designed to move AI beyond conversation and into action.
And this is where things become especially interesting because AI is shifting from answering questions, as it has been done for the past 2, 3 years, to completing tasks. For the past couple of years, most AI systems have been focused on just generating the content, answering questions, and assisting users. But Google's latest announcement suggests that the next phase is execution.
Meaning the AI doesn't just tell you how to do something, it actually helps do it.
Exactly, Tiffany. Google demonstrated systems at Google I/O capable of interacting across applications, managing multi-step tasks, retrieving information, coordinating workflows, and assisting users in increasingly autonomous way. So the focus is shifting from intelligence to agency.
And that's an important distinction because an AI that writes an email is useful. An AI that schedules a meeting, finds the available times, drafts the email, and sends it is operating very differently.
And that's right. The challenge moves from generating information to managing actions. And yes, that's where things become significantly more complex.
Well, we've spent decades learning software interfaces from menus, buttons, forms, dashboards.
And yes, increasingly the interface may simply become the intent. You describe the outcome, and the system determines the workflow.
Which sounds remarkably convenient until your AI accidentally books 3 flights to the wrong city because you forgot one detail.
And the machine followed instructions perfectly. The instructions were the problem, and that's a challenge familiar to anyone who's worked in technology.
Well, what's interesting to me is that this may be Google's biggest strategic advantage because, unlike many competitors, Google already owns the ecosystem: search, Android, Maps, Gmail, Calendar, Workspace, Cloud.
Honestly, it took Google a while to figure this out, but yeah, exactly. If agents become the next major computing platform, the integration matters. And yes, Google has spent decades building one of the largest digital ecosystems on the planet.
So the story may not be a better chatbot. It may be the emergence of software that increasingly acts on our behalf.
And yes, that could fundamentally change how good people interact with computers.
Interesting. One of the biggest stories this month may not have been a new AI model at all. It was the staggering amount of money being committed to AI infrastructure. From Anthropic's massive funding round to Alphabet's continued investment in data centers, chips, and AI capacity, the industry's largest players are spending at unprecedented levels. Johannes, it feels like the AI race is becoming an infrastructure race.
And yeah, I think that's exactly what's happening. A few years ago, the focus was primarily on algorithms and model performance. Today, the conversation increasingly revolves around compute, energy, networking, and physical infrastructure.
Because building a powerful model is only part of the challenge. You also have to run it, train it, scale it, and serve millions or billions of requests.
Exactly, and that requires enormous amount of resources: data centers, advanced chips, cooling systems, fiber networks, power generation, all the things people rarely think about when they open an AI application.
One thing that stood out to me this month is how much AI resembles traditional industrial competition. The winners aren't necessarily the companies with the best idea. They're often the companies that can build the largest supporting infrastructure.
And yes, historically, we've seen this before. We've been here with the railroads, with electricity, with telecommunications, with cloud computing. Eventually, infrastructure becomes a competitive edge.
And unlike software, infrastructure has physical limits. You need land, permits, construction crews, and electricity.
And increasingly, yes, you need a lot of electricity, which is why energy has become such an important part of the AI conversation. Some analysts now view power availability as one of the biggest constraints on future AI growth. And what's new this cycle is that the demand for compute is scaling faster than the infrastructure required to support it.
So when investors pour tens of billions into AI companies, they're not just funding software, they're funding a new generation of digital infrastructure.
That's exactly right, Tiffany. The AI race is no longer just a competition for intelligence, it's becoming a competition for capacity.
And that may end up being one of the most defining technology stories of this decade. Well, one of the more overlooked stories of this month came out of the continued expansion of large scale AI driven manufacturing systems, including new developments around Terafab style smart factory deployments. Across the industry, we've seen reports of manufacturers integrating AI systems directly into production lines, combining robotics, machine vision, predictive maintenance, and industrial IoT into unified factory environments. Johannes, this feels like AI is moving fully into the physical economy.
It really is, Tiffany. It is moving into the physical economy. And what's changing here isn't just automation. Factories have had automation for decades. What's new in this cycle is the coordination. These systems increasingly are connected end to end, meaning machines, sensors, and software are communicating in real time across the entire production process.
So instead of individual automated steps, you're getting a system that can monitor itself and adjust itself as it runs.
Exactly. In practice, that means factories where production systems don't just follow schedules, they respond to live conditions on the floor. If a sensor detects inefficiency or a machine starts drifting out of spec, the system can respond immediately, adjusting workflows, rerouting tasks, or triggering maintenance before failure occurs. That's what people mean when they talk about self-optimizing production.
Which is a very different idea from traditional manufacturing because historically, factories were reactive. Something broke and then you fixed it.
Yeah, that's the way his work. But now the goal is to shift away from that kind of reactive process to a predictive process and eventually an adaptive process. And once you reach that level, the factory starts to behave more like a dynamic system than a fixed production line.
And that's where the economic significance really starts to show up because small efficiency gains in manufacturing scale across entire supply chains.
And that is key, Tiffany. Even a few percentage points of improvement in uptime, waste reduction, or throughput can translate into enormous economic value at scale. And that's why companies are investing heavily in these integrated systems now.
So the real story here isn't just robotics or AI separately. It's the convergence of both into something closer to an intelligent production ecosystem.
And yes, once you see that clearly, you realize that this may be one of the most important industrial shifts happening anywhere in the economy right now.
Because once you can build the infrastructure, the next step is putting it to work in the physical world. And one of the most closely watched developments this month in robotics came from companies like Tesla, Figure, and several warehouse automation startups, which continue to move humanoid robotics from demonstration into early stage real world deployment planning. And what stood out about this cycle isn't just that robots are improving, it's that companies are beginning to talk openly about where these systems will actually be used at scale. And Johannes, this feels like a shift from lab testing to real economic integration.
It really does, Tiffany. So for a long time, humanoid robotics lived in the, well, this is impressive, but not yet practical category. So what's changing now is that we're starting to see structured deployment pathways, not general purpose robots everywhere, but very specific environments where the economics make sense.
Like warehouses, logistics centers, and manufacturing floors.
Exactly. Environments that are structured, repetitive, and highly optimized for task-based labor. And importantly, environments where companies already spend heavily on human labor for predictable physical work.
So the story isn't robots replacing everyone tomorrow, it's more targeted than that.
It is more targeted. It is selective automation. And that distinction matters because even limited deployment in the right sectors can reshape labor markets and operational costs very quickly.
Well, what I find interesting is how these companies are now framing robotics less as hardware experiments and more as workforce infrastructure.
And yes, that is a key shift. Once robotics moves into infrastructure thinking, the scaling logic changes. You're no longer asking if a robot can walk across a room. You're asking what portion of economic activity can be reliably automated.
And that's a much bigger question. Well, one of the most important corporate stories this month came from Meta, where internal restructuring continues to shift significant parts of the company toward AI focused priorities. While headlines focused on job reductions and organizational changes, the deeper story is that Meta is actively redesigning itself around artificial intelligence. And what's changed is the speed. This isn't a multi year restructuring, it's happening in near real time as AI capabilities evolve.
And when you look at it structurally, this is resource relocation or reallocation at scale. So talent, budgets, and engineering focus are being concentrated into AI systems, infrastructure, and long-term model development.
So the question becomes not just how many people are employed, but what type of work the organization is optimized for.
Right. And Meta is not unique here. They're just one of the most visible examples of what's happening. So across the tech sector, companies are increasingly asking what functions should be handled by AI systems, what should remain human-led, and how do those boundaries shift over time?
Which is very different from previous technology cycles because historically new tools changed workflows. Now they seem to be changing the organizational structure itself.
Yes, and that tends to be a more persistent kind of transformation. Once companies reorganize around this or a new capability, it's very difficult to reverse that structure later.
So this isn't just about Meta. It may be a preview of how large organizations everywhere will begin to evolve. And this shift in organization mirrors something happening in the physical systems underneath them. Industrial IoT continues expanding quietly this month with an increasing deployment of connected sensor networks across manufacturing, transportation, utilities, and agriculture. What's interesting here is that while AI gets most of the attention, it increasingly depends on this underlying layer of connected physical data. Johannes, this feels like the invisible backbone of the AI economy.
And that's a good way to put it, Tiffany. IoT systems are essentially the sensory layer of modern infrastructure. They collect real-time data from physical systems, temperature, vibration, flow rates, energy usage, and machine performance.
So AI doesn't just exist in the abstract, it's being fed constantly by real world signals.
And yes, when you combine that with modern machine learning systems, you move from monitoring to prediction.
Meaning systems can detect failures before they happen.
Yes, and predictive maintenance is one of the clearest examples. Machine doesn't just break randomly, it signals degradation ahead of time. And AI systems can interpret those signals early and early enough to intervene.
Which changes the economics of infrastructure because downtime in industrial systems can be extremely expensive.
And that's why IoT quietly becomes one of the most strategically important layers in the entire AI stack.
Cybersecurity professionals continue highlighting a growing concern this month: the rise of autonomous AI agents capable of taking actions inside digital systems. Unlike traditional AI tools, these systems don't just generate outputs. They can execute workflows, access tools, and interact with software environments directly.
Well, Tiffany, traditional cybersecurity was built around human behavior interacting with systems. But now you have software that behaves like an operator.
That's a great point because that means it can retrieve data, modify systems, trigger processes, and coordinate across applications.
Precisely. Traditional cybersecurity assumes software was a tool. Agent-based systems behave more like actors. And that introduces a new challenge because the risk is no longer just external intrusion, it's internal action by systems that are partially autonomous.
So cybersecurity starts to look less like perimeter defense and more like permission management.
And that's a very accurate way to put it. The key question becomes, what is the AI allowed to do and under what conditions?
Which sounds almost like designing governance systems for digital employees.
That's increasingly what it is. And unlike human employees, these systems operate at machine speed and scale.
Wow. One of the more forward-looking stories this month comes from the continued progress in quantum networking research, where scientists are moving closer to what is often described as quantum internet. Recent demonstrations have shown improved methods for quantum entanglement, distribution, and more stable transmission over longer distances. Johannes, this still feels very early stage, but increasingly real.
And that's the key distinction. We're not talking about consumer quantum internet tomorrow, but we are seeing foundational breakthroughs that make the concept less theoretical.
And the goal here isn't just faster communication.
No, it's a fundamentally different communication. Quantum networks leverage entanglement and quantum states to enable forms of secure transmission that classical systems cannot replicate.
Which could have major implications for things like government communications, finance, defense systems, and scientific collaboration.
Especially in those areas where security and integrity of information are critical.
Well, what stands out to me here is that this feels like one of those technologies that moves slowly for years and then suddenly becomes central infrastructure.
And that's often how foundational communication systems evolve.
Healthcare continues to be one of the most active areas for research and deployment this month, with new studies highlighting improvements in diagnostic accuracy, imaging interpretation, and early disease detection systems. What stands out is not a single breakthrough, but the steady accumulation of clinical validation across multiple domains. This feels like AI is quietly embedding itself into the medical system. Wouldn't you say, Johannes?
I would agree, Tiffany. It's a great way to describe it. Healthcare is one of the areas where AI strength and pattern recognition are especially valuable because medical data is complex, high volume, and often subtle in its signals.
So AI is becoming kind of a second layer of analysis.
Exactly. Assisting physicians by identifying patterns, flagging anomalies, and prioritizing cases that might otherwise be missed.
And importantly, not replacing doctors, for now, anyways.
No, that's not the purpose of this. The most successful models in healthcare tend to be collaborative. AI supports clinical judgment rather than replacing it. And that combination is where you tend to see the strongest real world impact.
Which may ultimately be the most sustainable model for AI in general. Next, let's talk about a story that may surprise some people. The Vatican issued one of its strongest statements yet on artificial intelligence, warning about the importance of protecting human dignity as AI becomes increasingly integrated into society. And Johannes, this just feels like one of those moments where you realize that AI has become so much bigger than just a technology.
And that's exactly right, Tiffany. So when religious institutions begin issuing guidance on emerging technology, it's usually a sign that those technologies are beginning to influence society at a fundamental level.
And I don't think that we've seen that before. But this isn't really about software. It's about human agency, human responsibility, and what role people should continue to play in decision making.
And you see, many of the concerns that are being raised overlap with the discussions that we've already seen from governments and universities, labor organizations, and ethicists. Questions like who remains accountable, what decisions should remain human, and how do we ensure technology serves people rather than the other way around.
Well, one thing that I find fascinating is that conversations about AI are increasingly happening in places that have nothing to do with Silicon Valley. Boardrooms, parliaments, classrooms, courtrooms, and now religious institutions.
Because the technology itself is expanding into all of those spaces. And whenever that happens, society starts asking larger questions than engineering alone can answer.
Ultimately, it's not simply how intelligent these systems become, but how humanity chooses to live alongside them. And finally, one of the strangest scientific stories of the month. Researchers created one of the largest Schrodinger's cat states ever observed.
Which sounds adorable until you remember that the cat is simultaneously existing in multiple quantum states.
A very complicated pet.
And yes, the significance here is that researchers continue pushing the boundary between the quantum world and the everyday world that we experience.
Trying to answer one of science's oldest questions, where exactly does quantum weirdness stop?
And the answer appears to be, well, we're still working on that.
Comforting. Well, across all of today's developments, a clear pattern is beginning to emerge. Technology is becoming increasingly autonomous. Not just generating information, but sensing, acting, optimizing, coordinating, and increasingly participating in real-world systems.
Which means that the future won't be defined by any single breakthrough. It will be defined by how these systems interact. AI, robotics, IoT, cybersecurity, quantum system, and infrastructure.
Because the biggest changes rarely happen when one technology advances. They happen when many technologies begin reinforcing one another, which we've witnessed for years during our virtual events and especially during our Industry Insights webinar series. At first, our Industry Insights webinars were focused on IoT, and quickly we saw that it wasn't just IoT being propelled by the pandemic, it was AI, robotics, drones, all these advanced technologies. So if these are the kind of conversations that are shaping your organization, industry, or strategy, we'd love to continue them with you at the Intelligent Thinking AI Summit 2026, taking place in July, or at the Summit of Things this October. These events will provide a high-level overview of the latest advancements in AI, IoT, edge, connectivity, and more. For speaking opportunities, sponsorships, or simply to register, you can visit iotmktg.com.
And before we close, I would like to mention one more thing, Tiffany. So at Google I/O, and we mentioned that in the newscast, Google announced what they described as the biggest upgrade to the search box in over 25 years. Search is no longer just 10 blue links. Increasingly, the answers being written by an AI model for the buyer before they ever reach your website. So here's the question. How is your company's AI visibility? And by AI visibility, I simply mean this. When someone asks Google, ChatGPT, or another AI model about your market, your category, or your competitors, does your company show up? And if it does, is it described correctly? For many businesses, that answer is not yet clear. And that, of course, is a risk. So this week, we're launching the AI Visibility Baseline, the first in a suite of diagnostic tools designed to help companies understand whether they are visible, missing, or misrepresented in AI-generated answers. Because in this next phase of search, being known by Google may matter as much as being found on Google. So thanks for joining us on TechScope News.
Thank you, Johannes, and thank you all for joining us. We'll see you next time. Bye-bye.
Bye-bye.